Alright, so today's lecture is on wireless networking issues and trends. So today we'll talk about one general thing, which is hype cycles of the technologies, as to how the technologies develop in general and when should we be working on those. Then we talk in general about the wireless, as to where the how the market is going, and then what the current latest trends are, what the current issues are. So wireless has been around for quite some time, over 100 years. However, we really started using it very recently. Believe it or not, networking didn't happen until 1997 and 1999, just 20 years ago. Before that, we talked about wireless networking, but we really didn't use it. So the real wireless networks came up with Wi-Fi 802.11, which was running at 2 megabits, and that actually didn't pick up very much. So that is the original 802.11 standard, and then 99 or so later we came up with B, 802.11b, which was running at 11 megabits, and then suddenly it picked it up. So today you cannot imagine a device, you cannot imagine a computer without Wi-Fi. In fact, there is no longer an option that you can buy a computer without Wi-Fi, but that was not the case just 10-15 years ago. So while there is a long history of analog wireless, the digital is very new itself, and the cell phones started in 1970s, and then the first wireless data network started at the University of Hawaii, called Aloha, and that's actually also the mother, let me put it, of all networking as well, because that Aloha project gave rise to what is now known as Ethernet, and on the wired networking we use Ethernet. That came from there, from wireless. So Ethernet was supposed to be the first wired protocol that was using wireless access methods, kind of thing. And then there were some proprietary LAN protocols, the local area network protocol, and WaveLAN, and several others. But the first standard came out in '97, and then so on and so forth. The rest, basically, that's when the network the wireless took off. And so next we talk about as to how some technologies take off and some don't. And so this is a curve, S-shaped curve, which applies to all the technologies. So every technology follows a life cycle where they begin life, and generally in the universities where there is very little, whereas it takes a lot of time to solve a very few problems. All the problems are very difficult. In terms of money, that means that it takes a lot of money to produce very little, and so it is done by people like you and me. Right? So that is the research phase of the technology. After the research has been done, and then people start promising all kinds of things that this technology will do, suddenly a hype is created, and then everybody jumps on it. At that point, basically, it takes very little time to solve a lot of problems, which means that it takes very little money to produce a lot more, and guess who takes over? Yeah, the industry comes in. That's where the startups come in. And then the hype is built, and more startup, more and more company come in, and at final point, the technology does deliver, but does not deliver everything that was promised. And therefore, a disillusionment sets in, and everybody walks off. A lot of people are forced to walk off. And that's the negative time. And after that, some realism comes in, and then the technology takes one of the two turns. Either it goes away forever, or it stays there, but it's not very much hype, it's a normal thing. And every technology goes through that curve. Every technology does, whether it is IP, whether it is TCP, whether it is computing, whether it is networking, whether it is aeronautics, whether it is chemical engineering. It doesn't matter. All the technologies have these 5 phases, and the people in the industry keep track of this every year because you don't want to be on the wrong side of the curve. Right? So every year, the marketing companies come up with their own graphs, and this graph is from Gartner Research, July 2009, and they put different technologies that are on which side of the curve. This is their view. Not that I agree with much of this, but I just want to show you that people publish these things and people take it very seriously. Billions of dollars are invested on the left side, billions of dollars are disinvested on the right side, and so on. All right, nobody wants to be on the wrong side of the curve, particularly when the real money is involved. Right? So this year they are predicting that quantum computing is here. The augmented reality is growing fast, and the wireless power. How do you transmit power without connecting? That's there. Cloud computing is the peak. Mesh networks are going down. RFID is at the bottom, and so on and so forth. All right. So if you are in a research area, then you generally want to be here before the knee. If you are a startup, you generally want to be on these technologies, and if you are working on these, you want to move off as soon as possible, whether you are in research or industry. And if you are here, then here money can be made. However, the thing is, at this point, the technology is stable, and the money is made by big companies then. Basically, the money is made by making it cheaper rather than better. All right? And so companies, not only different countries then take over that market, there are those that can make it cheaper. All right? So the companies that survive on innovation, they have to be on this side and not on the other side. So anyway, and this company, by the way, Gartner also produces, and there's a whole Harvard thesis, I suppose, or from the Harvard Business School about this hype cycle stuff. But this company, Gartner, produces hype cycles for every technology, and there's a lot of money to be made in just these hype cycles itself. So they have a hype cycle for wireless networking. Unfortunately, I could not put lay my hands on it because it cost several $1,000s to get that research. And so I got something which is 3 years old. And 3 years old today is really not very valuable, to tell you the fact. That's why they left it open. Okay, so this is in public domain. So I put the references where I got these graphs from. And these are my own graphs. Actually, some of these I have drawn myself. So if you see the real graph, that is very congested and you couldn't read it, so I have to draw it myself so you can read them. But for wireless people, near field communication is on the rise. Zigbee is on the rise. Now, right now we don't know what that is, so we will talk about that as we go along, but you might remember that these are something that are coming in. Mobile WiMAX is on the rise. But okay, when you say right now, this is all 3 years ago. Things have changed since then. All right? Many of the things which are on the left move on to the right every year. Right? So having said that, this is basically 3 years ago. This was on the rise. UWUSB was on the top. 11N was coming down. HSDPA was coming down. HSUPA was going up. Sensor networks are coming down, and mesh networking. Bluetooth is a commodity, and 802.11 ABG is a commodity. That's their view 3 years ago. Now things are moving to the right, as I said. Most of the technology moves to the right. So many of the things which are on the left will become on the right, and which are on the right will move further right. Yeah. Yeah. So now many of the words have been said here, and I haven't explained you what these are, but let me just briefly tell you what these are. HSUPA is high-speed 3G. I mean, actually it is, yeah, okay, high-speed 3G might be. So this is high-speed uplink access. Okay, and the other one is high-speed downlink access. So when you use for example, your iPhone and it says 3G, you are using HSUPA and HSDPA stuff. All right. And Zigbee is the technology for sensors, actually. So when you have devices at home which are communicating, the sensor devices, temperature sensors, and then smoke sensors and so on and so forth, they use Zigbee. Near field communication is a technology which is just coming in, which is more like RFID but very active. With that, you would be able to make payments without taking out your iPhone from your pocket. I mean, basically, probably you will take it out from your pocket, but you just show it to the device, other device, and the other device will charge whatever amount you authorize. So instead of credit cards, the cell phones will do the job by near field communication. So this is smaller than what we call personal area network, PAN. Bluetooth is a PAN, personal area network. It goes to a few meters, but this one will go less than a meter. Very small. Okay, now let's see. So you know UWB. I don't know. You don't know UWB. UWB is ultra wideband USB. So there is a version of USB which is which can give you almost 480 megabits wirelessly. But again, it is very short distance. 11N we already know, HSDPA, sensor, mesh, and Bluetooth and ABG, right? So everything is known on this slide now. Then let's talk about where the money is going in wireless, and the best way to find out that is by looking at where the telephone companies are making their money. And again, this data is a bit outdated, 2005. Things have changed since then in the last 3 years. But in 2000, and I have some later data, better data later on, but I couldn't find a detailed data like this, so I just left it alone here. So up on 2003 to 2008, and this graph is there in 2005, so this was projection then. This is where the telephone companies are making money. They were making 0.2 billion in video, 2.8 billion, and so on and so forth in different things out of 300 billion. So if you look at the bottom line, they have a growth rate of only 2.5% per year. But majority of the revenues are coming from this line, which is the wireless, and wireless is going from 95 to 153.6, and it is going at the rate of 10%. So the money, they are really making money in the wireless. All right. Everything else is going down in some sense. The wired is going down by minus 15%. Long distance is almost gone, 0, and so on and so forth. And so key to take from this graph is that most of the revenues are coming from wireless. So if you go to a phone company and ask for a job, what are they going to ask for? Wireless, right? And in the wireless, the second thing to notice is that wireless is cell phone. Obviously, I mean, the telephone companies, AT&T is making money in cell phone, not really in your home phone, right? So the point is, in the cell phone also, 26% is from data versus voice. All right, so data is growing. And that's the message I will show you in the next few graphs. That the phone company, the voice business is again there also is going down, and for different reasons. But really, the action is in wireless data. And so let's go on and move on to see some more graphs. So this is a 2009 graphs from ITU, and this shows the top graph, the green one, is cellular mobile telephony, how it is growing. And today, 67% of the world population, this is the world population, per 100 people, 67 people have cell phone access. Cell phone is ubiquitous. Internet is this red line, and internet is about quarter of the people have internet. And the next one is fixed telephone. That has not gone anywhere for the last 10-15 years. Stayed fixed. And then the DSL and the broadband is growing. But you notice that while broadband is growing so fast, internet is growing faster, and the fastest thing right now, the most action is in the cellular market. So again, if you teach a course in wireless networking, and if you don't teach about cellular networking, you are not doing the right thing. And this is how, by looking at these graphs, we decide what is more important to teach. So the summary is that really we need to know more about cellular market, cellular technology, and we need to know more about basically these things. Okay. Another thing by ITU also, same actually report, they also tell you where the action is, which part of the world the action is. So obviously there is a lot of action in Europe, the growth. The next one is Asia and Pacific, which is China, Korea, and so on and so forth. Actually, most of the action is in Japan and Korea. So most of that, 70% of that is in Korea and Japan. And then this blue thing is USA. No, not USA. This is America, which includes South America, North America, and everything else. But 80% of that is USA. And then the rest of the world, which basically is Africa and previous Soviet Union. Very little action. All right. So if you are in the business for this thing, then you obviously know where your markets are going to be or where they are. Okay. And then we talk about broadband wireless. What is broadband wireless? So for wireless, broadband means high speed, and generally we talk about access. What is access? Access is how it comes to you from a phone company. So it doesn't include Wi-Fi generally. And Wi-Fi is also an access method, but generally when you get your wireless access, you're getting it by 3G or in future by WiMAX. And another name you will hear a lot today and from now on is LTE, long-term evolution. So there are two technologies which are coming up, WiMAX and LTE, that will allow you the wireless access outside of your home. Okay, and so this is how they are growing. They are growing exponentially. That's where the most of the action is. So that's why we will spend quite a bit of time in this course on broadband. It's growing exponentially. Now let's just see a little bit more. And again, I couldn't find the latest data, so this is an old data, but then I have some later data, which is actually the latest one. But in 2004 itself, and this is from Korea, which is actually one of the leaders in communication right now, leading countries in communication, and they gave a boost to cellular technology, CDMA for example. They gave a boost to WiMAX. They were the first adopter. They are the earliest adopter. The country has decided that they want to be the leader in all these technologies. So they put money into these things. But anyway, so the idea is, so they have the data from early times, and you can see that between 2004 and 2008, the fixed voice, your fixed telephone, has gone down by 6%. Fixed data has gone up, which is DSL, has gone up by 4%. And mobile voice, which is cellular phone, has gone down in that country, and mobile data has gone up. Now, this CAGR means cumulative annual growth rate. Okay, so this is annual rate is 20% growth rate. So again, message is same. The message is what is growing most? Mobile data. So we have to worry about how to do mobile data. If you are AT&T, if you are Verizon, if you are Sprint today, what are you focusing on? Mobile data. All right, and that's where the markets are, where the jobs is, where the companies are. All right, now here is some more later data I could find, and so this is, I think 2007 report. I forgot to put the reference here. Oh, reference is right here. Instead 2007, September 2007, and this shows how the U.S. government spends money in 2007 and how they will spend in 2011. So you can compare and see where the growth is. So the wireline services are right now 70% of their spending in telecommunication, and it will become 53%. So you don't want to be in that market. You don't want to learn more about that. It's all done. Wireless voice is 24%, will become 26%. So yes, there is some growth from 3.9 billion to 3.5 billion. But the wireless data is where the growth is again. From 1.1 billion to 4.5, there is significant growth there. All right. Most of us academics actually don't look at these data. These things are just too business oriented. But as I said, I find it interesting, having come from business myself, that we really have to focus on things which matter outside. And so I can't teach you by using the same books that other people are teaching, and they're still teaching the same old Wi-Fi in the wireless course for a whole year. Okay? So, wireless data is where we want to be, and that's the whole summary. Now look at the research, and this is the latest data, January 2010. This is January 2010. Today is actually yesterday's data. If you go to the website on IEEE and see today, you will find this data. Right? So what people are reading, what we are reading, the academics are reading. These are the top 10 downloads. 7 of these are wireless. So that says something, that even if you are a researcher, if you are an academic and you are doing networking, communication magazine, by the way, this is Communication Society, so they do all kinds of networking, wireless, opticals, cellular, whatever. But most of the people are reading about wireless. All right, so what's happening in the wireless this year? And much of this actually is based upon this one report. So one could go more and spend more time, but things change so fast every year that whatever was happening last year is no longer good. So I have to just concentrate on whatever I could find the latest. And so these are things which are happening. Mobile data we already talked about, high-speed wireless access we talked about. Then things like this, and we have actually one slide on each of these. In the next 9 slides we'll talk about those. But we have femtocells, green networking, mobile applications, mobile computing, cloud computing, and so on and so forth. So let's just see one by one. Now it's no secret that iPhone has changed the world. Believe it or not, that's the true statement. The whole telecommunication market has changed. iPhone is actually a combination of phone and computing. So it has changed computing as well. It's a better computer than a computer. It's a better phone than a phone. And so now both of the markets, both phone and the computing markets, are following the iPhone lead. And today there are 33 million iPhones, and the 3G networks cannot cope with that. Third generation cellular phone that are designed for data, by the way, they cannot handle the cellular data traffic that is being generated. And so we need 4G, and 4G is LTE and WiMAX. LTE and WiMAX, actually the next slide describes that, but let me just explain to you. WiMAX is like Wi-Fi, but more like a cell phone. They put a tower in the city, and you get transmission where you can connect to you at a very high speed. In fact, this computer that I'm using right now, it has a WiMAX in it along with Wi-Fi. All right, except that we don't have a service in St. Louis. Okay, if I was in a city where they have a service, I would be connected whether I'm here or outside. Wi-Fi can only reach a building, inside a building. Right, it's a local area technology. WiMAX is a metropolitan area technology, MAN. LTE is a similar thing, but it is designed by the cell phone companies. So it's after the WiMAX came out, then they said, no, we want to design our own version of it, and they call it long-term evolution, LTE. So that is coming. All right? And so let us talk about that. High-speed metropolitan area networks. So 3G provides you 192 to 512 kilobits per user. And although they might claim 3.6 megabits, but that is the total system capacity, and they divide it among so many users. So if you get 192, you feel very good. That is 192 kilobits, right? WiMAX is here, and it gives you 3 to 6 megabits. Clearwire is selling WiMAX in 24 markets as of last very recent report. In fact, next slide I plotted. I took their graphs of where they're available. So they are mostly available in the East Coast and the West Coast and maybe South, but not here in the middle. So we are far away. The only dot here looks like this must be Chicago. All right, so we are quite far away in this market, but it is available in 24 markets here, and this gives you almost DSL rates on wireless. So it is in some sense DSL replacement. You can forget DSL and just WiMAX service. Long-term evolution is coming. Verizon plans to launch next year in 30 markets, and AT&T in 2011, a year later. Following that is a new standard coming up called 802.16m. So 16E was around, 16E came out in 2005, and that's what is selling right now, mobile WiMAX. But what is coming is the next generation WiMAX, 16M. The standard just came out this year, and we will be talking about 16M in this course again because we want to talk about the latest things. So 16M has been standardized by IEEE, and that is what we call 4G technology. That's going to give you 100 megabits per second on wireless. Right? Again, 100 megabit is total system, and when they give it to 100 people, it will be 1 megabit per person. But actually, you can buy 100 megabit if you have enough money. So that's the story. And following that is LTE Advanced. So LTE has a next generation called LTE Advanced, which is very high speed. Okay, both of them in the same range of 100 megabits. All right, so one of the things is, how can you get all this capacity in the wireless? The spectrum hasn't changed any, right? The spectrum that was available yesterday is available today, but we have become smarter. And how have we become smarter? That's what we'll talk about in this course. Another new technology coming in this year, or last 2-3 years, and you haven't seen it yet, but it's coming, is femtocells. So we have big cells, macro cells, micro cells, and nano cells, and now we have femtocell. Femto, as you know, is the unit like milli and so on and so forth. I forget how many 10⁻⁻15 or so. I forget. Femtocells. So that is a cell that just covers your home. A cellular tower for your home. So you get it from the phone company, a femtocell device. It will let your cell phone work, connect to that. And so right now, when you go inside the home, the signal is not very good, particularly if you live in suburbs. Right? If you go inside a home or inside a building like this, the cell phone signal is not good. You put a femtocell device, and it connects because it uses the same frequency, so your phone doesn't know that it is not connected outside. It connects to the same thing inside, and you get a very high data rate because it is connected wiredly from that point on. So it is a wire from your home to, by a DSL kind of thing, to the phone company, but inside your home it is wireless. Not only it is wireless, it is also completely connected in the sense that if you are talking on your phone in your home and you walk out to your car, the phone is connected. It doesn't get disconnected. And then you go, so basically it transfers. Basically, it is transfer from one cell to the other. So we'll talk about that femtocell thing. Actually, there's a new term I read yesterday called liquid connectivity. Liquid connectivity means that the connectivity is not like wired connectivity right now. If you're watching a movie, at home on the computer, you can transfer it to your cell phone inside your home, and you can transfer it to your car inside your car, and you can transfer it to desktop on your desktop. Liquid connectivity. That's coming. All right, so what is happening in the mobile networking area? Well, we saw that 75%, almost 67% of the world population has cellular access, so that has several problems too. One problem is that there are so many cell phones are thrown out every year that there is a problem of recycling them, or landfill and things like that, right? And So that is one thing. Second thing, they need energy. So how do we save energy? And energy savings actually counted not just in use, but also when we make them and when we throw them. Right? So several issues have come up. First of all, we need better batteries. So people are planning, are claiming to have designed better batteries which charge very fast and then they last longer. Right now, the rechargeable batteries don't last longer than a year. You buy anything rechargeable, it will be good for 1 year. Next year, the batteries have to be changed. And and you can charge them about 1,000 times. After that, they are no longer good. But people are now claiming better batteries which can maybe 5,000 times. Energy saving modes, and that is actually the key saver, is that nowadays we are designing protocols that allow us to save energy. They allow us to go to sleep, and your cell phone goes to sleep every few milliseconds and then comes back up, and that's how it can stay longer. Recyclable handset. We want to design cell phones that are made from recycled materials, so they are basically don't basically consume what we call carbon dioxide or produce carbon dioxide, and then they are recycled again, reused again. Recycling of the handset. Reduced power consumption at the base station. Now, base stations are big power consumers. They have kilowatts of power being consumed at the base stations, and there is basically not only we want to reduce that power, but we also want to use renewable energy. Generally, these towers are anyway on the mountain. We might as well put a solar panel there and then use what we call renewable energy, right? Energy that doesn't basically is gone forever. All right, so that is one of the key trends, is green networking, and actually we will talk about power issues in wireless later on in more detail. Another craze is mobile apps, and it has just, as I said, iPhone has changed the world, and so they claim 2 billion apps in 15 months have been downloaded in the last 15 months, and basically this is where most of the phone companies are looking for money, and the device manufacturers, Apple and other companies. There are 30 different stores have been started following that kind of thing. And mobile presence is critical. Now, if you're in a business of any kind today, so there was an NRI in 94, then everybody just started learning that they want to be on the internet, and .com boom started. Everybody wanted to have an internet website. Today, you want to have an iPhone app for your company. If you are a Facebook, if you are a Twitter, if you are anything which you do with the public and you don't have an app, if you are a newspaper, if you don't have an app, then you are not being watched. So both the computing and this, obviously there are hundreds of copy designs of iPhone style, and every company has come up with their own model of this. So cell phone companies are following iPhone, but even the computing industry is following iPhone. So that brings us to the mobile computing. So the computing today is truly mobile, in the sense that we really don't stop computing when we get out of the home anymore. Most users read email, news, internet tasks on iPhone. In 2008, netbooks outsold desktop computers. So netbooks is the reduced computer. And so most people are buying netbooks. I mean, they cost me $300, $299. And the new notebooks are similar to iPhone. Now the new one that will be coming in would be more like iPhone. Apple tablet is to be announced later this month. It has not been announced, but it is to be announced maybe this week, and which will be very much like this. Solid state storage drives. So these things they don't have moving mass storage, moving drives. They have solid state drives, so that is growing. And what is coming is hybrid drives. They found out that the solid state drives, while they're good, but they're very expensive. The mobile drives are cheap. Now you can buy terabyte drives for $100. They are very cheap, but but they are not as fast as solid state. So there is hybrid where they put two drives right on one. So you are reading and writing from SSD, but that's only a cache. The real thing goes for long term on the hard drive. So you get both the cost effectiveness of the real hard drive, and you get the speed of SSD. Next generation phones will have better keyboarding experience. Now another thing which is coming in is how do you input? The human interface is changing, and again, people have tried all kinds of things. I remember I started with this palm handwriting thing where you have to make symbols to write A, B, C, D. Then I started the keyboards, and now there is this iPhone touchstone keyboard, which is still not perfect yet, and people are perfecting that as well. All right. So that is mobile computing. But where is mobile computing going? It is going into the clouds. What is a cloud computing? Cloud computing is where you do all the real work in a faraway place, and all you do is your display at your place. All right. So if you have a dumb computer on your desk, and most of your job is being done in a server at Google or Amazon, that is called cloud computing. So today you could go to Google and do your Google Docs. How many of you have done Google Docs? Right? Yeah, so most of you. Good. So you know that you can do all your Excel, Microsoft Word, and whatever you wanted to do right in a remote place, and that is called cloud computing. So you are already using cloud computing. Right? And with the cell phone, it is even more necessary. Right? With the cell phone, the power at your end is very limited, and power at the other end is very much. Right? So we are going more into cloud computing, and that means all the computing is going to go on the browser, and therefore Google and company have come up with Android, which is a mobile operating system, open source code, Java-based applications. So that's where the world is heading. Totally open operating system, total open source operating system. You can just download the Android source code from Google and start working on it. It's like Linux. Then there is mobile-based augmented reality. So what is augmented reality? Augmented reality is basically you have combined both real, which is reality, and the virtual in real time. Real time is reality. So you take whatever you have, reality, for example, your location could be real, but the view you are seeing could be virtual. It could be a real photo, but you could be seeing a virtual photo. And so, for example, there is an iPhone app where you can look at the sky. You look at the sky, and you start your camera, by the way, before that. So when you start your camera and look at the sky, the iPhone sees the real sky, and then it will tell you, well, here's Uranus, here is this and that. Previously, you couldn't figure out which star is where. Right? But now it will show you right there in big, basically on your screen. This is this is that. So that is augmented reality. Is that you have the real thing, but now you can see better. You take it to a place, let's say downtown St. Louis, and you start your camera and you look at a street, and it will tell you, well, you know that building has Wi-Fi there. Go inside on the left. Go on the right. You took your camera, take it to a parking lot, and you open it, and then it will say, no, you have to go left for your car. So the camera can see. Right? So that is augmented reality. Interesting photo applications. You can see your friends in every shape and size, and you can see, port your camera towards a friend, you can see how they will look, without clothes or with clothes and things like that. All kinds of funny things are happening on the iPhone world. You should go and see on the iPhone apps page. So all kinds of fun things, but virtual reality things are happening. Near field communication, next. Near field communication, as I said, is a technology which is very much like RFID, and I would call it active RFID, because passive RFID means that they don't have any power source connected to it. So if you take a box from a store, they have an RFID into it, but that has no power in it. There is no battery in it. And so the power comes wirelessly from the device that is reading it. But with the near field communication, both sides have power. Your cell phone has a power, and the device that is reading it has a power. Right? So that is called near field communication. It needs very little power, but then you can do some interesting things. And so there are phones, for example, Nokia came up with a phone which has NFC, and you could just charge, you could use it as a credit card. All right, that brings us to the end of this part of the lecture. So the summary of this part is just to motivate you and to myself as well, where the action is and what we'll be talking about, what we should be teaching, what should be learning about in this course in wireless. And so the summary is, if you are doing networking today, wireless is thing to be. Okay? Because that's where the phone companies are making money, that's where the Intel is making money, that's where the Google is making money, that is where the Microsoft is making money. So, regardless of whether you are a IC company, whether you are a phone company, whether you are a web company, wireless is where the action is. In the wireless, it's the data where the action is, not the voice. All right, this should be clear to you by now. And even in the wireless, we're not talking about the fixed wireless. There used to be a fixed wireless before where you keep your antenna on the outside and fixed. No longer people want that. We are moving all the time, so we need more mobile wireless. All right, so those are the 4 key points to remember. I have all these references that I have used. I have put here, you don't have to read them, but I mean, it will be good if you want to read them and get more details. And actually, I read a lot more, but these are the ones that I took information from.